1.3. I am going to be sitting up here just to record the lecture, so I won't walk back there here for today here. So we're at 1.3. We got addition of real numbers, something you've already seen in pre-algebra. And if you take a look at 1.4, it's going to be the subtraction of real numbers, something you learned in pre-algebra. Just real quick here, those that are new, if you're absolutely bored in chapter 1, you're in a good spot, okay? Because this first chapter is pretty much the exact same like last chapter that you've seen in pre-algebra. And so it's they just cut and pasted. That's all they did. So we're just kind of reviewing pre-algebra. So let's go for it. How do we add real numbers? How do we add fractions, decimals, and particularly sign numbers? That's what we want to look at. How do we add negatives and positives here? So how do we add negative and positive numbers together? Well, this one little demonstration here, if you started off when you lost $3 already when you began playing poker, and then you lost another $4, you're going to add those losses together, right? So you're going to be, in a sense, you're going to be -7. So notice, even with negatives, you're still doing the same thing that you would do with positives, right? So you got -3 plus -4 makes a -7. So normally what happens is we start off using a number line for it. So let's do this one. We'll do later. It's 1, 2, and 3. I'm going to change the order up on the lecture notes. We're going to jump to 4, 5, and the others first. Maybe you guys did this pre-algebra. Just let's review it just real quick here. How do we add numbers and how do we think about adding numbers? And then we'll develop some quick rules for it, right? So let's just look at a number line only. So how do we use a number line to add up numbers? So what we do is the first number that you use right over here, that's your starting position. So 6 would be our starting position. We put a little dot at 6. And then that little 4 at the end, that little +4, that's how much we move. That's it. So this is like fundamental things of adding numbers up, right? This is total grade school, but we're going to move up real quickly after this. So first number is your starting position. Second number is your move position. And if it is a positive number, there it is. If it's a positive number, we move to the right. If it's a negative number, we move to the left. That's all it is. So here we go. From the 6, we're going to go 1, 2, 3, 4, and we put a little dot there. That's our ending position, and we've just added 6 plus 4. Again, totally rudimentary. If we had to, we would all be walking around with number lines in our pockets, and we just take them out. We're like, oh, okay, we go like this, like this, like this. Okay, it's 10. Not a very practical way to live life, right? So we're going to have to develop some better, more sophisticated stuff. But it all starts off with this number line. So the next one, starting position is what? 3. And we're going to move 8 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8. Put a little dot there. We finished off at 5. Voila. And again, very, very basic stuff, beyond basic. But we should notice some rules and patterns that we're going to develop that are going to be based off of this, because those rules better work exactly how the number line works. And if it doesn't, if those rules don't, then we don't have very good rules. All right, next one. Number 6 and 7. Here it is. Got to do all 4 types here. So number 4 is positive, positive. Number 5 was positive, negative. Now we're going to work with negative, positive, and negative, negative. All right, let's go for it here. So starting position is -7. We're going to go 11 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's our little 4. We good? All right, and the final case, the negative case. What happens here? We start off at -3. And we go 5 to the left. 1, 2, 3, 4, 5. In position is -8. Okay, so how does this work? Well, last time we learned something called absolute value, didn't we? Absolute value, what happens here is we forget about the sign altogether. We just make it positive. Cool. And this one's a good illustration here. The rules that we have developed, which will be on the next slide, so we don't have to walk around with number lines in our pockets all the time. We developed 2 rules. It's very simple. They work all the time. We're good to go. Here's the rule. For number 6, let's show it as a rule here. Let's see if I can write. Nah. Okay. So for let me do number 6 is as far as a rule is concerned here. Ah, it's down here, that's why. Okay, that's right. All right, as far as a rule is concerned, here they are. If you have the same signs, let me do it like this. There it is. Same signs. If you have the same signs, all we're going to do is we're going to take the absolute value of the numbers. Good? So forget about the signs entirely. Who cares if they're negative or positives? If they're the same, we're going to get rid of the signs and we're going to add up the numbers themselves. And then we're just going to put the same sign that we had for both of them, or it's called the common sign. So if the 2 numbers were positive, forget about the sign entirely, add them up, keep the positive sign. If the 2 numbers were negative, forget about the signs, we add up the numbers, and we just put the negative sign. Okay, if the 2 signs are different, here it is. We forget about the signs, except we subtract the smaller one from the bigger one. And then we have a choice. We're going to always put the sign of our bigger absolute value number. So let's see how this works here. Let's jump to it and let's look at some examples here. So 1, 2, and 3. And again, if you know this already, Mr. Ace, this is so easy. I know the stuff. No problemo. I'll throw in some fun ones in here. Kind of for those of you that say, Mr. Ace, this is so boring. Get some fractions, get some decimals in here. Stir it up a little bit here. Okay, so here we go. I'm going to do it the easy way. Now, real quick here. So some of you guys have done it enough times that it's almost like it's just quick. You just see it like, oh, I know the answer is. I know the answer is. And that's cool. You should get to that point. We're good? So some people, they look at it for a little while and they have some tricks in their head that they've used in order to get to where they need to get to. We're good? Then you got the other people that really need to go step by step. Okay? So I'll try to cover all those. All right, so 5 and -8. First things first, same signs or different signs? Different signs. So here's what we're going to do. We're going to take the absolute value of the numbers. This is the rudimentary way of doing it, right? We're going to take the absolute value of the numbers, but we're going to make sure that the bigger absolute value number is on top, always. Good? So absolute value -8, that's going to be bigger than +5, so that's going to go on top. Absolute value 5 is 5, and then the question is, do we add or subtract? Subtract. We're going to subtract because there are different signs. One's a positive, one's a negative. So we do this, we subtract, get ourselves a 3. Then the only thing is it a positive 3 or a negative 3? We're going to look back to see which one's the bigger absolute value number was 8. And then the sign, original sign of it was negative. So answer finally is a -3. Are we good? Totally. So real quick here. We stepped off the number line, right? No need for a number line in our pockets anymore, right? We got to the point of, we got this little rule in our head that we can do this with, right? Okay. For these simple problems, eventually, I want you guys to get to the point to say, look, I have 5 positive and I have 8 negative. Who's going to win? It's like tug of war, right? There's tug of war. You got 5 positives and 8 negatives. The negatives are going to win by 3, is that right? So for these little problems with like 1-digit numbers, those are so easy to think about. That's how the way you should do it. You should just think, okay, there's more negatives than positives. There's 3 more negatives than positives. It's -3. Okay. If you got to that point, you're doing great. That's where you should be. All right. If you need to sort of do this slowly still, that's fine too. So let's do it the slow method. We'll do it the fast method. Here we go. -9 and +6, different signs. Is that right? That's okay. Any which way. Let's take the absolute value of both of those. Since they're different signs, we're going to subtract again. So 9 minus 6 is a 3. And now the choice is 3 negative or positive? It's negative. So 9 was the bigger absolute value number. The original sign of 9 was a negative. It's a -3. Oh, awesome. Cool. That's awesome. We'll get more sophisticated. Okay, add. -8, -4. Same sign or different signs? They're same. You got a -8 and a -4. So we're still going to take the absolute value of it. But this time, because of the same, we're just going to add them up. So 8 plus 4 is 12. Then we look back to see what was the common sign. What was the sign that they both of them had? Negative. Answer -12. Okay, again, starting out very simple. We went from a number line, went to this little rule, and hopefully I think most of you guys can probably do that kind of in your head real quick with the small numbers. Reason why we're looking at it is because sometimes when you get to decimals, sometimes we get to fractions, you do have to go back to these little rules again, because like, oh shucks, what do I do? I got to go back to these fundamentals to do them. That's all. But for the most part, I think we should be able just to look at it, say who wins. Okay, that's cool. Let's go on. All right, so number 8. Here it is. Just for practice sake here, can we add all combinations of positive and negative numbers of 11 and 15? So the combinations are positive, positive, negative, positive. Then you have a positive, negative, and then you have a negative, negative, right? Those are the 4 combinations that you have. So let me set it up for you already. So here's your positive, positive case. And then here's your negative, positive. Let's switch it around. Let's go positive, negative. And then let's go negative, negative. I notice I do put a parenthesis around the -15. We normally would do that because the plus sign is the operation, and then that little negative sign, we want to make sure that it's part of the 15 number. So usually whenever you have negative numbers in back of an operation already, we put parentheses around. All right, all yours. Go for it. 1, 2, 3, 4 real quick. It's going to take you like a whole 6 seconds, maybe, or 8 seconds. All right, let's go 11 and 15. That one we should know already. That's easy. Don't even need to think about it. It's going to be a 26, right? And again, if you wanted to go back to the rules, you could, but nah. Why go back to rules if you could do it already the easy way? We've been doing this since second grade. All right.
Third grade.
Third grade, okay. All right, next, -11 and +15. Let's see, different signs, or let's do it the faster way. You got -11, you got 11 negatives, and you got 15 positives. What do we got? We got 4. This one you have 11 positives and 15 negatives.
-4.
Now the negatives outweighs the positives, is that right? And then this one, easy. Since they're both the common, we're going to add them up, put the little negative sign, we're done. Okay, one more for you. Number 9, same exact. Way of doing it, if you go from beginning to end, go for it. It's part of your homework exercises as well to tell you to do that. All right, I think I'm ready here. So positive case. You got the negative positive, got the positive negative, and you got the negative negative case there, just like the previous problem. Good there. And let's go for it here. How about a 35 for the first one? The difference of 15 and 20 would be 5, so it's a positive 5 because the positives went out. Next time, the negatives are going to win out by 5. And the last one, they're both negative, so let's add them up, put a little negative sign there. We're good to go. Just at a quick little curiosity for me, how many got all 4 correct? Simple, Mr. H, this is easy. Is this course even going to get any more difficult? Yes, it will. Okay, now let's jump to, let's jump order of operations with this stuff. So we learned order of operations last time. And let's do this here. Since we did order of operations already, I'm going to give you like maybe 2 minutes here. 2 minutes, try 10, 11, and 12. Just for a little while here. All right, let's go for it here. So the way I would do number 10, looking at this here, I'm going to go from left to right. So I'm going to put these guys together first. So -7 and 4, -3, that comes down. Then you still have the little -6 inside parentheses. So from there, -3 and -6 will make a -9, right? Both of them are negative, add them up, put the negative sign there, done. Okay, that's a straight from left to right combination right there. On number 11, certain things change because now you have brackets and you have parentheses. So now what we're going to do is we're going to concentrate just on the stuff inside the brackets only. That's going to go first. So 4 and -7, -3. And you can keep the brackets there if you like. You can actually change the brackets into parentheses. Brackets usually change into parentheses if there's no other parentheses inside them. So they automatically change to that, but that's fine. Once you get rid of all the stuff inside, you've simplified each of your parentheses. Now it goes from right to left. So -5 and -3, -8, -8 and -3, -11 at the end, which I heard someone say already. That's cool. All right. Next, same thing as number 11, just with only parentheses here. So the first thing we got to do is just the stuff right here. It looks like the -8 is inside parentheses, but it's inside parentheses because of the negative. We're good? Totally different reason why. The -5 and the 11 are inside parentheses because it tells you got to do that one first. Right. So -5 and 11, 6, or +6. Cool, +6. Okay, here, now order of operations, remember last time, can't go from left to right. We're not ready for that yet because we have a multiplication in our hands. Yep, 2 times 6 has to go first. Got to multiply if you can multiply, right? Okay, here is the fun one. Whenever you have a number and its opposite, That's the only quirk to this. They just cancel, yeah. Whenever you have a number and its opposite, all we do is we just slash them out. They're gone. See you later. They become zeros, and the answer is -8. All right, another show of hands, just real quick here. Raise your hand if you got all three correct. Just want to see. Going once, going twice. Hands up, hands up. Ooh, that's not cool. About 45% of you, a little bit less than half. Let's see, let's do this just out of curiosity here. Show of hands here, real quick here. How many got 10 correct? Number 10, number 10, number 10 correct? And keep your hands up. How many got number 11 correct? 11 correct, 11 correct? How many got number 12 correct? See, that's when it went down. So what's up, you guys? What happened with number 12?
All I missed was I was going too fast and I didn't see that it was multiplication instead of adding.
Got it, okay. Didn't see the multiplication. Any other reason for getting 12 incorrect? Pretty good for that? Okay.
I have a question though.
Yep.
On 11, in general, well, on 11 and in general, as long as they're all the same, not sign, but the same function, like, you're doing addition and subtraction on both of them. Can't you just group them?
All right, and then let's go back to this here. Arithmetic sequences. I think last time we looked at 3 different types, right? We had, Fibonacci sequence. Remember that? We looked at that, something like that, right? So we looked at all 3 types. We looked at the arithmetic sequence when we're adding a number. We looked at the geometric sequence when we're multiplying a number. Today, we're going to look a little more in depth at the arithmetic sequence. So arithmetic sequences we're just adding the same number over and over to get the next one. So real quick here, 2 goes to 5, 5 goes to 8, 8 goes to 11. What's happening there? Adding 3 each time, right? You're adding, there's a 3 there, there's a 3 there, and it just keeps on going, and then you get to the 14, and then you can keep on going still. So we're going to just sort of practice with that. Are they easy? Yes. Do they get sophisticated? Yes. So let's jam here. So number 13, I got an A, B, and C. Give you guys a minute or so. The directions are for each sequence in arithmetic sequence, find the next 2 numbers here. Find the next 2 numbers. So A should be pretty easy. B has some decimals in it over there. Got to think about the decimals there. And C probably is another easy one here. So I just need the next 2 terms as they go. All right, let's go for it here. So, easy one here. 6 goes to 13, 13 goes to 20. The answer is, what are we doing?
Add 7.
Add 7. Perfect. And with that, so if you add 7 and 20, it makes 27. Add 7 more makes 34. There are your 2 numbers there. We're good. Okay, B. 2.5 goes to 6, and then 6 goes to 9.5.
Well, what's the next one?
Cool, all right. Adding 3.5 each time, first of all, right? And you can kind of just guess. The 6 to 9.5 is probably the easiest one. You go from 6, you're going to go to 9, that's 3 already, and then you have to add an extra half, or 0.5, 3.5. All right, 3.5 plus 6, there's your 9.5, just confirmation there. And then we go to the next one here. 9.5 plus a 3.5 makes 13 is the next one. And then perfect. The next one, adding another 3.5 gets you a 16.5. Perfect. There they are. So answers for B would be 13, 16.5. And C, you start off with negative numbers already. So negative 6 goes to 0, and then 0 goes to 6.
12 and 18.
Perfect. You're adding 6 each time. Kind of gives it away, because if you're starting at negative 6 and you get to 0, you got to be adding positive 6, right? So 12 and 18 are good. So all right, there's the addition. We just learned addition. No need for number lines in our pockets, right? We got this little rule that helps us. And this little rule helps us with decimals. It helps us with fractions. It helps us all over the place just with this. Same signs, add them up, put the common sign. Different signs, subtract one from the other. Put the sign of the bigger absolute value number. So then we get to subtraction. Then we have ourselves a little problem. Because if we want, we can develop 2 more rules. We good? That's an option. We can develop 2 more rules for subtraction. They'll be different from the addition rules. So then we have 2 rules for addition, 2 rules for subtraction. And that's cool. Except there's a little better way. How about this? How about whenever we need to, we'll just convert subtraction back to addition. That's what we're going to do. And so how do we do it? Is this little rule right here. So if you're going to subtract, so if it's a minus b is the exact same thing as a plus a negative b. So it's almost like adding the opposite. And so that's a cool thing because we don't have to develop any new rules. All we do is whenever we see subtraction, if we need to, we're going to change it back to addition by this little guy. And then we'll use the exact same rules we just learned in 1.3. We good? So let's try it. So it says subtract all possible combinations of positive and negative numbers of 9 and 6. Let me give you all the possibilities because mine is listed a little bit different than what I did before. So 9 minus 6, 9 minus negative 6, negative 9 minus 6, and then negative 9 minus the negative 6. There's positive, 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 negative, negative, positive, negative, negative. The only problem is with subtraction, you can't stop there. Because if you say all the different possible combinations, you're going to switch them around as well. So here's the other set. What happens if the 6 was first? 6 minus 9? Negative 6 minus 9? 6 minus a negative 9, and then negative 6 minus a negative 9. Oh man, there's more combinations here. For addition, didn't talk about it. But if you switch the order around, you're still going to get the same numbers. We're going to talk about that later in the commutative property of addition. But subtraction, now you got to do all those. Okay, so what do we do here? If you can do it like we did in 3rd grade, then we don't need to switch it. But if it gets a little more sophisticated, then we switch it back to addition. Like the first one you see, 9 minus 6. Do I really want to switch that to addition, or do I know that pretty well already? Yeah, 9 minus 6 is 3. We're good. Don't need to switch that at all. Okay. But the other ones, we may want to switch. So let's do that. So we don't have a rule for subtracting negatives, and then you have another rule for subtracting. Ooh, it's going to be crazy. So let's do this here. We're going to take this little subtraction symbol here. And funny thing is in mathematics, real quick here, you got that symbol and you got that symbol. They look the same, right? But they are totally different. This guy is an operation symbol. This is telling you what to do. We good? This little symbol, even though it looks the same, is saying that this is a negative number. We good? So one is subtract, one is negative. Even though they look exactly the same, they mean totally different things. Okay, let's go for it here. So the way you change stuff to addition is you go change the sign, change the operation, and you take the opposite of the number back. We good? So here it is. We're going to put a plus sign here. And what's the opposite of negative 6? Positive 6, right? So you go like this. Boom, boom. Positive, positive. That's how you get positive, positive. Next one. We're going to change this guy to a positive, except what's the opposite of 6? Negative 6. And we go all the way down. So this becomes positive, positive. This becomes positive, negative, positive, negative, positive, positive, and then positive, positive. Okay, why are we doing it? Because we don't want to develop other rules for subtraction. We want to keep the rules for addition. Also, we're going to find out if everything's addition, it's actually even easier to add up. So there'll be another shortcut we learn. Cool. Hey, that's the end of my stuff here. You guys can do that from now on. Go for it. Can you obey the addition rules from 1.3? Go for it. So look at it. We're back to 1.3. So no new rules. Go for it. Can you finish it off using now addition? All right, so 9 and 6, that's easy. Positive 9, positive 6, that's 15. Well, are we good there? Then you guys tell me here. Negative 9 and negative 6. Negative 15, okay. Negative 9, positive 6. Negative 3, right? I think it's negative 3, yeah. So negatives went out by 3 right here. All right, positive 6 and negative 9. Negative 3. Negative 6, negative 9. Negative 15. Positive 6, positive 9. 15. And negative 6, positive 9. Positive 3. Cool. So go down the list here just to check your answers here. There they are. Are we good there? I think so. We're cool by that. All right. Any questions on 1? Anyone like, Mr. H, how did you get that to become a negative and that's still a negative? All right, we're good? Okay, you guys get number 2. Let me just set it up just so you guys know which numbers I did. Here's my setup for it. Follows the same pattern as number 1. I think I got them all here. Let me just check here. Okay, so go for it. All right, I would probably start off with the one I can do right away without changing it to addition. There's 1 in there. And then the rest I would change to addition. And then use the addition properties. All right, let's go on here. So the one I can do right away is this one right here, right? This middle one, 14 minus 7 is 7. Right? I didn't change it up, but you can change it up. I mean, I changed it up. You don't have to. All right, I put pluses in there. Just check your answers. I got negatives now. So I got negative 14, negative 14. Positive 14, positive 14. Negative 7, positive 7, positive 7, going all the way down. We good? And the answers, here they are. Just check yourself to see if you got the same exact ones I do. All right. I hope you guys got the same order I did, right? Hope you guys copied down the way I did. All right, real quick here. Any questions on if you got different one than I did? Mr. H, the third one down, how did you get? Or is it just too easy, Mr. H? It's boring, Mr. H. Well, hope maybe I could take a nap here. Is that boring? That's okay. End of chapter 2 will be kind of fun. Fun, I have to pay attention. Okay. We good with that? That's the subtraction. Any questions on number 2? Going once, going twice? All right. Let's jump to order of operations with this stuff. Let you copy those down first. Go for it. All right, so let's go for it here. So first things first, for letter A, thinking what I'm going to do, I'm going to change this little minus sign to a plus sign. for operation change. So 8 stays the same, -2 stays the same. But a negative, or sorry, subtract 7 changes into a plus -7. Are we good there for the change? We changed the operation to a plus sign. +7 changes to a -7. I included the parentheses just for the fun of it. Okay, once that is set, the rest of it is just addition. So here we go. From left to right, 8 and -2 make 6. 6 and -7 make -1. Boom, done. Okay, for B. Ooh, I see this. I see a subtracting a -3. I'm going to change it to addition. So plus there, opposite of -3, +3. Then I'm going to do the same thing that I did with the -7. I'm going to change it to a plus, and that's going to be a -5 this time. So quick change. Notice in the middle one, I can drop the parenthesis now. We good? No need for the parenthesis. If you kept the parenthesis, that's still fine. But let's go for it here. The only thing set is just addition. So from left to right, 9 plus 3 is 12 plus -5. +7. Good. Done. Okay. This one throws you for a little loop because this parenthesis is not to make a negative out of it. This parenthesis because it tells you to do this first. So -5 plus 2. -3. Notice I haven't changed the operation yet, right? I kept the operations the same because I'm working inside that parenthesis first. I don't care what's on the outside yet. I've simplified the parenthesis. I'm awesome. Next is change all my operations to additions. So this guy changes, this guy will change. This guy changes, the 4 becomes a negative. So rewritten in just in terms of addition only. Yeah, wait just a little bit. I see some people writing things down. I see some people racing really quick here. So let me slow down. So it changed my operations, changed the signs in back. Boom. And now the fun part. -3 and +3. Cancel. They're done. So I'm just left with a -4. So that becomes a 0 if you like. 0 and -4 make -4. Okay, let's go with, let's see, two more order of operation problems. Now, of course, we get some multiplication in here for the fun of it. We get some exponents in here. So I'll give you guys maybe like a minute here. Try it yourself from beginning to end. So copy it down, then try the problem. All right, I'm going to go for it here. So number 4, I'm looking at this. There's no parentheses. That's good. No exponents. Even better. Any multiplication or division? Yes. And they're all separate from each other, right? 6 and 8 is a multiply. 5 and 7 is a multiply. 3 and 4 is a multiply. So I can do them all at the same time. So there it is. Okay, now this one, if you change it to addition, that's cool. But did you need to change it to addition? No, you know that 48 minus 35, we can do that, right? That's something we can do. 48 minus 35, if you need to do it off to the side, 8 minus 5 is 3, 4 minus 1 is 13, perfect. Bring it in, 13 minus 12, do we need to change that? Nah, that's stuff we learned in 2nd grade. 13 minus 12, 1, and done. Are we good there? Now, if you did change it to addition, no problem. This way you actually had extra work to do. But you still should have wound up with 1. So especially with subtraction, you want to consider real quick here, do I need to change it to? It's a lot easier to do without. All right, number 5, no parentheses, but I do have exponents. Exponents are separate from each other. So let's keep the 4 as is, but 3 times 3 is 9. Keep the 5 and 2 times 2 times 2. So 2 times 2 is 4. Times 2 again, or doubling that, gives you an 8. Now we're back to where we were with number 4. We've got 2 multiplications separate from each other. That's going to be 36 and 40. Good. Yep, now we change it because 36 minus 40, not something we could do. So let's change that to addition, put a little -40 there, and see if you guys can do this in your head real quick here. You got 36 positives and you got -40s, 40 negatives. Who's going to win? The negatives are going to win by 4. Okay. All right, and two sets of problems here. So I got 4 problems ahead of us here. And then we're going to jump to a geometry problem real quick here. So this one is taken from English into mathematics. So when you take things from English into mathematics, sometimes it goes forward. Sometimes you got to think about it as backwards. So if you say subtract 8 from -4, careful, remember this, keep it in your head. If you're subtracting from something, that something better come first. We're good? So subtract 8 from -4, the -4 has to go first. And then you subtract 8 from that. We're good? So the way you say it in English is the exact opposite way you would write it in mathematics. Careful with that one. That was the one that always gets mixed up. All right, once you get that, go for it. What is -4 minus 8? I think I'm going to change it to addition. Let me change it to addition, then that 8 becomes a -8, and then once I see that, then like, oh yeah, that's easy. -12. Both of them are negatives, add them up, put that little negative sign there. So number 7, all yours, go for it. Just real quick, write it out the way you normally write it in math, and then solve the problem. All right, just want to make sure if you caught on to something here. So subtract -7 from 5. 5 goes first, minus sign comes in, but then this time you would probably put in parentheses here. We good? Because the operation and then the parentheses holding that as a -7. All right, in this case, should I change the operation? Absolutely. Change the operation. Take the opposite of -7, which is +7. This one's even easier because this guy is just 12. All right, and the one that students mix this up with, that's what we're doing this, is this something called the difference. The difference, you do this exactly forward the way it says. So this is not backwards. This is, we call it a forward method. Find the difference of 10 and 6. It's straight as you say it. The difference means that there's going to be a subtraction symbol. Subtraction symbol between the 10 and the 6. So it comes in like this. It goes 10 minus 6.
So for finding the difference, you're kind of like, if you're thinking of the number, we're thinking of what's the space in between those two number spaces, which is why that one, like, if you just look at the two numbers, it's different.
Perfect. Yep. That's cool because the difference really is like the difference is you're looking at the space between the 6 and the 10. That's it. So it's 6 minus 10. Don't need to change this to addition, right? No need to. This is the easy one. That's just 4. Find the difference of 6 and -7. When you plug this one in, notice what we're going to do. We're going to put a little parenthesis because you have a negative number after a operation. All right, in this case, I would change this one now. Change this guy into an addition. Take the opposite, and 13 would be the final answer. And this is still, if you look at, if you put 6 on a number line, you put -7 on a number line, if you were to count it, there would be 13 spaces. Okay, geometry, here we go. So we got complementary and supplementary angles. One little tidbit beforehand. I think I mentioned this on Tuesday, right? You notice at West Hills College, there's no geometry class. What happened to geometry? We have Math 61, which is introductory algebra. You have Math 63, which is intermediate algebra. So then there's no geometry class. Therefore, what we do is we infuse geometry into the algebra classes. It's kind of integrated into it here. So these are one of those things right here. So the concept of complementary and supplementary angles, you know that if you go a full radius, a full circle has 360 degrees. And then we broke this up into what happens if it's a quarter of a circle. What happens if it's just a fourth of a circle? Well, that means there is 90 degrees here. And if you kind of cut this into two different angles, We have complementary angles. They're just two angles that add up to 90 degrees. That's what they are. If you go half a circle, that'll be 180. So supplementary angles are angles that add up to give you 180 degrees. All right, and then there's also an algebra way of writing it here. So x plus y equals 90. As we get into chapter 2, we'll see how this changes here. But x plus y equals 90, that's the way we normally write it. The algebra method of writing it, though, is like this. So you can plug in stuff directly. So x is equal to 90 minus y. So if you use the algebra method, all you got to do is just plug in and you get the other one right away. And that's exactly what you want to do. In algebra, you want to solve for a variable. So therefore, the equation is so easy to plug into. And lots of algebra. If you think of lots of algebra, when you do sort of sophisticated algebra, it's made so that whenever you're going to really use it, you're using almost at a pre-algebra level. You want to simplify as much as you can. It's kind of like technology does the same. You figure, I have a key fob, right? I press a little button, and my car opens up, and I'm like, yeah, cool, I can get inside, right? But to actually use it, right? I'd have to learn physics. I'd have to learn how radio waves transmit one to the other. I have to learn frequency. I have to learn electronics, right? We don't know any of that. We press a little button, and that's about it, right? So science, math, we kind of tend to do that. We tend to make stuff with science and math, and then we bring it to the general public where you press the thumb. That's about it. We had this discussion in another class. In California, I don't know if you guys know, the law was passed this year. Oh, it was passed last year in order to start this year. This year is a pilot year for self-driving cars. So auto manufacturers have this year to test self-driving cars, and then I think there's a grace period. So starting about 2020, I think, maybe 2019. No, it's 2020 or 2021. You can buy an automated car. So I figure in 20 years, I wonder if people will know how to drive a car. That's my question. You know, it's going to be so easy, right? The technology has led us to this point. You know, I remember my brother told me I had to learn how to drive stick shift. Raise your hand if you guys know how to drive stick shift. Like 40% of us know how to drive stick shift now because everybody drives automatic, right? So I figured 20 years from now, will people even, like, we'll be raising our hands, do you know how to drive a car? And like, there'll be 10 of us that will raise our hands, and that's about it. So, that technology, kind of fun. You kind of wonder, is it too much? All right, the algebra for supplementary angles, there it is, x is equal to 180 minus y, and we'll finish up with this problem right here. Really easy. The formula is already made for you, just like our algebra formulas. Remember from over there? Area and perimeter formulas. You just plug it in, you're done. That's exactly what it's made for. So number 10A and number 10B. Find x for the following diagrams. So we're going to use a formula that's already been solved for x. And so in this case, we want to use the formula that's already been solved. It was x minus 90 minus y, right? Or x equals 90 minus y. I should have wrote it up here. X is equal to 90 minus y. At this point, we're just going to plug in the 25 wherever we need to. All right, do we need to change it to addition, or we can do it just like that? Just like that, huh? So yeah, 90 minus 25, anybody? 65, x equals 65, and at that point, since we're trying to find something, it's not just an algebra problem, we want to label it. So 65 degrees, you've got to put that little degree symbol in there. Almost bless you. All right, supplementary angles, here it is. The formula is given, and then we can plug in the formula. X is equal to 180 minus 60. Do we need to change to addition? Not at all, right? No need to change to addition. And then we give the answer with the unit value that we need. So how about 120 is where we go. All right, and that is the end of 1.4.